Alright guys, welcome back to another Unreal Engine 4 tutorial. Today we're going to be making a magnet that behaves in two different ways. It involves a magnet and a coin. The first behavior is more of a cartoony behavior where you turn on the magnet and it kind of just pulls everything towards you, like as if you're when you run towards an object in certain games, things will just magnetize right towards you, and once it collides with you, it adds to a counter or something like that. We're going to make that, and then we're going to make a version where it's more realistic, where we're going to be using physics objects and forces to actually kind of push and pull coins or balls or whatever towards the player. So to get started, the first thing you need to know is that I'm using the most up-to-date version of Unreal Engine 4, that's 4.12.5, and I'm using the first-person template with the starter content. And inside of our character, the first-person character, I removed all the VR-related stuff in 4.12 and higher. It gives you all this VR stuff, some components, a construction script event here, and some stuff in the event graph that has to do with VR stuff. So we don't need that. We could just nuke that. We can remove that. And all we're left here is with the bare skeleton that we would usually get. And the first thing I want to do is we need to have some event that we want to call that turns on and off our magnet. So what I want to do is create an input action event. So to do that, we need to be in the main viewport here. We'll go to Edit, and then Project Settings, and then Input, and then under Action Mappings, I have one here created called Turn On Magnet. So to create that, just hit this plus sign. You can name this whatever you want, and then you just assign either a gamepad button, a keyboard button, a mouse button, whatever you want. In this case, I'm using Enter. And to see if that's working, we can go into the event graph of our character. Just type in turn on magnet, and we could just toss in a print string. Now if we play, hit enter, we're getting all this hello, so we know it's working. We just take out the print string. We're going to leave this event here. We're going to use it later. So in my content browser, I created a folder called My Blueprints and then a subfolder called Coin Magnet. In here is where we're going to create our first blueprint. It's going to be the coin. So we want to right click, blueprint class, actor, call it BP underscore coin. And in here we're going to need two components. We're going to need a static mesh component for our coin, and then we're also going to need a collision component just so we can get overlap events correctly and everything like that. So let's add a component. We'll do static mesh. We'll call this coin mesh. And we'll add one more component. We'll type in sphere, put in sphere collision. We'll call this coin collision. And then we're going to make the coin collision the parent of coin mesh, just so they stick to each other. And now we need to actually assign a static mesh. So let's click on that. We'll type in sphere. And if you have the starter content, you'll have shape underscore sphere. Put that in. That. And now we want to better align everything here. So what we can do is in our construction script, well, actually, not in the construction script. What we'll do first, we'll need to unparent that. So the coin mesh, we'll kind of just move down a little bit. Just the way things are rooted here. That looks center. Now we can put the coin collision back as a child, the coin mesh. And what we could do, to dynamically set the scale of our collision correctly, is we can grab the coin collision, type in sphere radius, set sphere radius. And what we're going to set it to what we'll need is our coin mesh. We need to get its local bounds, so basically, its size, and we get a min and max value. And under the assumption that we're always going to uniformly scale this object, what we can do is just take the max x and subtract from it the minimum x. So basically, we get on the x, how big it is. So if the max is 10 and min is 1, we know it's about 9 units wide. We just type and plug that in, and then we get this size. Now, if we want to make it smaller and tighter here, we can take this result, divide it by 1.75. I found was a good number, and now it's nice and tight there. And now if we actually throw it into the environment, we can make it like 0.5, and the collisions staying the same size. You can make it 0.2 if you want. You can do anything, make it 2. But the size we want is about 0.4. So we'll leave that here. And by default, we want to, for the first magnet that we're making, it's going to be the more cartoony one. So we want to keep simulate physics off. We want this thing to just float in the air like that. So that's perfect how we want it. So now we can get into the meat of everything here. Excuse me. So what we'll need first is some overlap events. So let's select our coin collision here, and then add event, begin overlap. And what we'll want to do, we want to make sure that with this coin, it gets destroyed or disappears, or we count it only when the player touches it. So from other actor, let's just cast a first person character. And then from there, we'll just do a print string. And now if we play in our game and we just run up to it and touch it, we get hello in the corner. So that's exactly what we want. Now let's take the print string out, and we'll leave this alone. The main logic of everything is actually going to be coming from the tick. So we'll first want to make a variable out of delta seconds. So we'll just call it delta seconds. Just because we want to keep track of tick, we're going to use that for linear interpolation of our object. And now, because we're working with tick, the best thing to use here is a gate, so we can control when we actually pass through our information and when we stop it. So what we'll do now is we'll make a custom event, and we'll call this move to player. We're going to call this whenever our magnet, when we create that, whenever our magnet overlaps our coin, we want the coin then to pull towards the player. So we're going to use that event here to do that, and we're going to open the gate there. But we'll also create a custom event, and we'll call it close gate, just so we have a means to close our gate if we have to. Now, what we're going to do is, again, we need to interpolate the coin's position from wherever it's at to where the player is. So to do that, we're going to need our coin mesh, and we're going to set its world location. And what we're going to set it to, what we'll need to do is do a a vector. So we should find let's type in v-interp. Here we go. So v-interp2. So let's immediately just put the return value in. And now our current position, that's going to be our coin mesh, and we're going to get its world location. And then our target, is going to be our player. So what we can do is simply just get our player character. So get player character, get mesh, and get world location. And now for delta time, that's where our delta seconds comes in. And then interp speed, this is really what's going to dictate how fast the coin is going to magnetically pull towards the player. So for that, let's just create a variable. So let's just pull from it and promote the variable. And we'll call this magnet speed. We'll make it a public variable. By default, we'll put it at 1 and we'll leave it at 1. So that's pretty much the main logic in our coin. So what we'll need to do now is actually make our magnet. So let's go back into our content browser, into our blueprint folder. Let's right click, do blueprint class actor, BP underscore magnet, we'll call it. And our magnet is only really gonna be a sphere collision. Let's type in sphere collision. We'll call it magnet collision. And we can just take out all this stuff here. Now we'll need to select our magnet collision, right click, collision, add on begin overlap. And the magnet's going to detect only the coins. So other actor, we're going to cast to coin. And for now, we're just going to do a print string. And what we're going to do really quick is event begin play. What we're going to do, we're going to set its sphere radius. We're going to make this a variable. We'll call this magnet radius. Make it public. And we're also going to check expose on pawn. And what that does is whenever you spawn an actor of class, whenever that actor has an expose on pawn, expose on spawn variable checked, you'll have access to that variable as soon as you spawn it. So when we spawn our magnet, we could just tell it, hey, be this radius at whatever time. So that's set up too. So basically what we'll do now is go into our first person character. We're going to use from our pressed is a flip flop, just so when we press enter first time, turns on the magnet, press it a second time, turns off our magnet. That's basically the functionality of that. So on flip flop, what we're going to do from A is spawn actor from class, find our magnet, and right here you see magnet radius. That's what I was telling you about. We'll make this 2048 is big enough. And then from here, we'll just promote this to a variable so we can call it. And we'll call this magnet. And that's all we're going to do for right now. Oh, and for spawn transform, we forgot to do that. Let's get our mesh, get its transform, get world transform, plug that in. But what else we want to do is attach the magnet to our cells. So attach actor to actor, parent actor is going to be self. And everything else should be able to be default. Check that. And last thing in our magnet, let's select our collision. And let's scroll, find hidden in game. Let's just make that false so that we can actually see it. Now if we compile, save, and play, if we hit enter, there's our magnet. So we know it's working. So awesome, great, cool. So when our magnet hits the coin, instead of having a print string, we're going to get that coin, and we're going to actually call the function move to player. Now, if I hit enter, it moves to us. And it'll continue to try to move to us. So that's great. So what we'll want to do at that point is if our coin overlaps us as the player, we'll want to, for right now, we'll just destroy that actor. Enter. So it hit, okay, I know what we did. I always do this. So right now we're destroying the player. We don't want to do that. We just want to do destroy actor by itself. We don't want to attach that. So that was my bad. So just destroy actor, target being self, and we're in the coin here. So when the coin overlaps the character, it'll destroy itself. Hit enter, and it's destroyed. Awesome. So now, if we want to deal with multiple magnets, multiple coins, so let's create 2 more, so now there's 3 in total. What I'd like to do inside the magnet is I want to create a variable. We'll call this coins, make it an array, and variable type coin, so BP coin. Make it public just in case we need it. I don't think we will, but it won't hurt us. And then we'll grab coins and add to it the coin that we overlap. Plug that in. So now we have an array of coins that we're going to use in just a second. But now if we hit enter, all 3, boop, 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 we got it. We're good. Collected all of them. But now we kind of want to work with the whole toggling aspect of it. So if we hit enter a second time, what we'll first want to do is see if our magnet is valid. It's just a standard check. It should be, but it's nice to have this kind of check just to avoid any kind of errors. So if it is valid, we'll get our magnet, we'll get the coins, do a for each loop. So we're going to go through all the coins that we overlapped with. We want to check if they're still valid. So is valid. And then if they are, we want to close that gate, make them stop moving. And then when that's all said and done, we want to take our magnet and our coins. We just want to clear that array. We want to kind of just wipe it out, start fresh for when we press it again. So we're going to do that on the complete. Now, hit enter a second time, they stop where they're at, hit enter again, they'll stop. Hit enter, and they're too far away, but if I go in, they'll start following. One problem that we'll have right now is we're going to be creating multiple magnets at a time. Like each time we press enter, so if I press enter, I create a magnet. Press enter again, turns off that magnet. Hit enter a second time, there's another magnet, and so on. And we keep creating magnets. Not efficient, not what we want to do. So we could go about it two different ways. What I want to do is, after we clear the coin, I just want to destroy our magnet. Simple enough. The other way you can go about it is, instead of destroying it, what you could do is have a valid check here. And if it's already valid, don't spawn a new one. But if it's not valid, create a new one. But I prefer just destroying it. And now, hit enter. Enter a second time, it's gone. And enter, there it is. Enter again, it's gone. And we got it working. So the last thing we're going to do for this magnet is create a HUD, UMG HUD element. So in our coin magnet blueprint folder, let's go ahead and right click, go down to user interface, and we'll select widget blueprint, call this BPUI, and we'll call it coin counter. Now, what I'd like to do is grab a text, just put it right here. We'll make it huge, 50, and we'll size the content, and we'll make the position here 50 and 50, just so it's kind of in the corner. File that. Now we haven't hooked everything up correctly yet, but we have at least something for our UI. So now we can go to the first person character. And for right now, in the event begin play, this is where we'll create our HUD. So pull from that, and we'll do create widget. And there's our BP coin counter. And then from the return value, we'll add to viewport. Now, if we play in our game, we see text block in the corner, which is exactly what we'd expect. But let's add actual functionality to this. And what we'll do is, in our character, create a variable, call it number of coins. Make that an integer. Make it public because we'll have to access it. And then in our coin, whenever our coin hits the player, we want to add to our coin counter because essentially we got the coin. So from our first person character, let's just get number of coins. And now there's a neat little function. If you just hit ++, you'll get an increment macro. And it'll just add 1 to it each time. Then plug that back into destroy actor. Now, last thing we need to do in our coin counter is, for our text, there's a bind option. We're going to create a binding. And I like to rename these things, so get number of coins. What we could do is get character, or actually we can get owning player pawn, cast to first person character. We can right click on this and convert it to a pure cast, because right now with a pure cast, it's under your assumption that it's always going to be this, so there's no real reason to have a on fail option. So from that pure cast, get number of coins, and then just plug it into our string, and it'll convert it for us. And that's it. File, save everything. Now we have a big old 0, which makes sense. And if we hit enter, 1, 2, 3. So that's all working. So in the coin for this cartoony magnet one, all we're doing is interpolating its world position from its current world location to the player's mesh location using delta seconds and a magnet speed option. So if we make this like 10, for example, these things are going to come at us really quick. And if you make it like 0.2, they're going to be moving pretty slow. So you can kind of like avoid them. So the main logic all is really in the coin with this. And then again, we have our gate where we can open and close it using the custom events move to player and close gate. In the magnet, all we're really doing is setting the sphere radius at the start, and then whenever it gets overlapped, we cast it to the coin, add it to our list of coins, and then call its function, move to player, and then in the character, this is where we put our UMG here. We create the widget and add it to our viewport, and then on the turn on magnet input action on flip flop, this is where we spawn and attach our magnet to the player. And also we have the spawn expose on pawn variable magnet radius, set that to 2048. And then when we want to turn our magnet off, we check if it's valid, we get its coins array, check if the coin is valid, and then close its gate, tell it to stop moving, clear the coin list, and then destroy our magnet. So that's pretty much it. So now for the more realistic magnet, we're not going to have to change that much. All of it's really going to be in our coin. So the first thing we're going to do is go into our coin mesh, turn on simulate physics, file, save, and we'll play really quick just to see if they fall. They do. If we hit enter, they'll kind of look like they're working, but instead of using set world location and all that, we'll actually use more of a physics function. So let's get our coin mesh. We're going to do add force. We're going to check acceleration change. To be honest, it doesn't really matter if this is turned on or off right now, so pick your poison. But the most important thing is to figure out what our force is going to be. The force is actually going to be the direction vector between the coin and the player. So luckily we have this information right here. So you can just copy, paste, and then from the get world location, we're going to do get direction vector. So the from is going to be the coin mesh location. The to is going to be the player mesh location. And the return just goes into the force. So now, that's not working. Let me see. Maybe acceleration change has to be false. Let's see. I'm silly. What we'll need to do next is multiply this by a float. And this float, we can use the magnet speed variable. Plug that back in. So we need to multiply it by an actual force amount. Right now we're telling it the direction, but we're not really telling it to go there pretty much. So magnet speed, we'll make this 1. Now if we compile, hit enter, you can see they're slowly coming. But if we increase the speed, we'll see this more of a drastic effect. Or not. Try checking acceleration here. Okay, they're moving a little faster. I'm guessing the number just has to be super high. So let's make it 1,000. Just for fun. There we go. There we go. Oh god. You can also have the coin counter. See, this guy's trying to come at me. So it looks like the number was just needed to be drastic. So if you set it to 1,000, you'll get exactly what you kind of want. And you can turn it off too. And what's kind of cool is they're physics objects. So if I turn on the magnet, turn it off, just get out of the way, they'll roll, do their own thing. Then if I turn it on again, they're going to come after me. And it's kind of fun to see them kind of swirl around, because if eventually they'll kind of just orbit you like kind of like a planet around the sun. And I can turn it off again, and they just go flying. Turn it on again, they'll be like, whoop. So that's pretty cool. So the only difference we had to do was one, make our coin mesh simulate physics, and then we had to use add force instead of set world location. And in the add force, we get the direction vector between the coin's location and the player's location. And then we multiply that by a magnet force value, a float value. And we had to make it 1,000 just so it was visible. So that wraps it up for this tutorial, guys. Thanks so much for watching, and I'll see you on the next one.